Welcome back, everybody, to the Additive Snack Podcast. This is part 2 of our Additive Snack series with America Makes. You recently heard from Kimberly, and now we are joined by Dr. Ed Herderick. He is the Director of Education and Workforce Development at America Makes, and therefore I'm super excited to talk to him about everything that surrounds training, workforce development, education, but also really the future of additive manufacturing that, of course, stands over the shoulders of all of us and the next generation of additive manufacturing engineers, professionals, and managers. Ed has been in the additive manufacturing industry for over a decade. He's been thinking about materials, workforce development, integration of additive manufacturing across industries, and therefore is now heading up the education and workforce development activities at America Makes. So therefore, we'll dive into all of these topics within this episode today, from the early days of additive manufacturing to where we are today, all the way into what all of that means for us in the US, but also really globally to build a capable and future-ready workforce. Therefore, without any further ado, Ed, welcome to Additive Snack.
Thanks, Fabian. Thanks for having me.
It's awesome.
Excited to share my passion this morning.
Yeah, me too. I think those are all topics where you and I share a joint passion. Obviously, I'm also very heavily involved in workforce development. So it's something I think about every day. And I'd like to start out with just kind of your perspective on looking back throughout your career and through your involvement in additive. How has the industry matured from a technology perspective, but also from a workforce perspective? What has changed over the years?
Yeah, I mean, that's a really great question to start with. So what I think has been true the whole time is what makes additive manufacturing a really special suite of technologies is it brings together design thinking, artistic thinking, and engineering, sort of heavy manufacturing. And, I have a close friend in the industry. I think a lot of us know Dr. Yuping Gao. I was having coffee with Yuping a little while ago, and he said he loves 3D printing and additive manufacturing because he gets to do art and engineering for his profession. And I think that that really sums it up nicely because, if you look back, all the way back, early 80s, when all these technologies were being invented, it really brings together some interesting personalities and some sort of interesting end market verticals, right? So the same technologies that we're using to design, heavy manufacturing products like, gas turbines for power plants and jet engines is the same technology we're using for creative arts and artistic expression. So that, to me, is a thread throughout the entire history of this industry, and one that we still hold today. And I'm really sort of both hopeful and bullish that we'll continue maintaining that thread even as the industry grows. I think that's the biggest difference I've seen is, when I started my career, it's kind of interesting to hear and have these conversations now, because I started my career in the early 2000s. And honestly, I felt like I was late to the game in additive manufacturing because there have been so many terrific innovators that I really looked up to, your founder, Hans Lanner, and the Lanner family being among them. Looking up to those folks and thinking, oh my gosh, I'm late to the game. How much of this have I missed?
Yeah.
And now it's funny to look back however many years later, and it's like, oh man, we were just getting started. And so now, I don't know, maybe it's an age thing, but now I feel like we're just getting started still in a very positive way. I think the difference is, again, in certain ways, this is not a new technology. In other ways, in industrially relevant ways, it kind of is a new technology, right? I mean, it wasn't obvious in those early days that we were ever going to be able to make fully dense, high performance industrial materials in high volume in the way that's happening today. So if I tie that back to education, workforce development, even 10 years ago, maybe even pre-COVID, so less than 10 years ago, there was still this really strong thread of a lot of generalists being involved in the industry. That's still true, but I think that cohort, it is sort of remaining the same, but there's specialists that are adding a lot of value and really growing the industry in interesting ways. And what I mean by that is, for the longest time, you sort of had to be a software expert, a materials expert, a mechatronics expert, a laser expert if you were using lasers, like a small, maybe not, one person, but in a small group, you had to have a ton of expertise in order to successfully deploy projects in a cost-effective and sort of time-effective manner. Now, where I see this sort of growth trajectory of the industry, and what I think the industry's done a good job is all these other specialties can access and participate in the industrial additive manufacturing industry in a way that, really wasn't possible a few years ago. And so to me, this is a sign of a growing and industrializing industry. And again, it goes back, if you were talking about education, workforce development, well, now you can be a sort of pure play design engineer, or let's just say product designer. Because again, some of these are, consumer products, or again, artistic expression, like people are making movies, F1 race cars. There's all kinds of great products we could talk about this morning. So I think there's a lot of room for specialists to participate in a way that wasn't true before. Mm-hmm. And that is providing a lot of opportunity for workforce and education that also, again, it's just more accessible in a way than it was before.
Yeah. No, I mean, those are interesting points. I like your point of view on, or Yuping's point of view on art meets engineering. I think some of our colleagues in the industry maybe need to remind themselves that this is a really awesome, you get used to that aspect, right? That you have that a bit of more creative freedom than in other manufacturing technologies, right? You're still not only developing new designs, you're developing new support strategies or nesting strategies, new process parameters as part of that. So there is that creative aspect that is actually a lot of fun, I think, for folks in the industry.
Yeah, super fun.
But on the other hand, it's also that these job roles are maturing and are becoming more, I want to say standardized, but a bit more, pure play, as you I think called it, right? You'll start to split these roles into very specialized focus areas, and that is, of course, for the companies and organizations that are really that have already adopted additive in a serious way. But I think there's this whole other cohort of companies that are still so early to the technology or hasn't adopted it at all. What are, from your perspective, some of the misconceptions around additive for those organizations from a technology perspective, but also from a workforce perspective, right? Because it does also seem daunting to deploy a new technology like additive without having that backbone of pure play additive knowledge experts.
I think there's a couple trends. Maybe I'll sort of answer your thread here in two ways, mm-hmm. right? I'll share a couple other sort of industry trends that I have convictions around, and then sort of talk about how it fits with the workforce and training element. So, I mean, one thing that's super important for any company or just person that's interested in this field is recognition that it's actually a pretty broad suite of technology and tools, right? Like, even if you just look at the ASTM definitions, that were developed, whatever it's probably been 15 years now. right? That was 7 different categories, and then there's subcategories in those 7 categories. So it's really kind of a broad suite of materials and processes. I think the other thing that, again, makes it really high value, but can be a challenge in its adoption is, it's really going back on that riff of why is additive a special technology from a technical perspective. For me, it brings together product design and material science, materials performance, materials engineering in some really unique ways. That's not to say other technologies don't have the same ability, but the accessibility just isn't the same, right? So like a small cohort of enthusiastic product designers can really drive things really far, really fast, using these technologies in a thoughtful way. But that's a double-edged sword. So if we're looking for broad adoption, again, then you get into this sort of process selection, understanding the scope of processes, and then you get into all these, like, fundamentally, engineering is a business enterprise, right? So you've got to think about productivity, dollar cost productivity, time productivity, lean manufacturing on your shop floor. So there's this whole sort of continuum of decisions that you want to make in order to select your category that's going to be right for your business. And then there's all the other things of, which vendors are you working with, what, and materials and machine, like there's just a lot of energy that goes into sort of really thoughtfully selecting what corner of the additive manufacturing universe is applicable. Where I think that ties into education workforce development, and in particular, what we're doing in the EWD pillar for America Makes, is we have lots of terrific content for folks that want to learn about additive. And we have lots of terrific members who also have made lots of content. So if you want to go learn about any or all of the 7 categories, what materials they can make, how fast they run, even some of the costing, like that information is available. But what I'm really excited about doing, where I think our industry is really driving it into segmented industry vertical niches. So rather than 3D printing just as a tool, it's 3D printing for XYZ. I'll give 2 examples, right? And these are 2 examples we're working on right now at the Institute, and 2 examples that I sort of think sort of prove the discussion, right? One is around 3D printing for small class 1 UAVs for a number of both commercial and defense applications. It's sort of an interest item. I don't know that it was any much more than that. And then I started to talk to our Institute members and stakeholders, and sort of like every conversation built on the last conversation, and was like, whoa, we really got something here. And so I think that, it's like 3D printing for what? For insert the application. Another really interesting one that we have a lot of activity around is additive manufacturing for castings and forgings, which is really interesting because, if I think back to the early days of this industry, there was a lot of discussion both from the casting foundries and the forge houses on, is additive a collaborator or threat? And there's a lot of discussion from the additive industry of, look, additive is trying to add value. We're not trying to replace these other industries. And now it's gotten to a productivity level where it can add value to those industries. So they can add, edge capacity without, significant capital investment in the same ways. It gives them more flexibility in meeting orders. And then again, from a workforce perspective, it's really, really helpful for learners or businesses that want to get into the industry, because then instead of giving them this whole spectrum or this of like, hundreds of pages or thousands of pages and, hundreds of vendors, it's like, oh, okay, there have been some really terrific innovators and entrepreneurs that have been thinking hard about this industry, for, if you look at castings and forgings, I mean, really, they were in some ways some of the early adopters of additive technology. And it's not even just that I'm making castings and forgings with additive tech. It's like, okay, how do I integrate them together? Maybe I'm looking at joining or inspection or some of these other things that, again, get into this product design element. And then it narrows the universe. And then it's like really, really accessible in a way that can show ROI, whether I'm somebody who's trying to upskill and want to know where I'm going to spend some time, to learn a new skill or maybe get into a new industry or grow my career, or if I'm a business that I'm looking to invest in the technology. So I think that's sort of like 3D printing or additive manufacturing for insert here. I think that's, maybe it's not a new theme, but I see just a lot of traction and a lot of interest, particularly for that sort of next group of adopters.
No, I would agree. And I think also the technology is starting to lend itself to be more specialized for certain applications, right? Years ago, you would have just standard process parameters that you would apply to most applications. In today's world, every application has, or at least every production application does have custom parameters to really push the limits of the technology. You are starting to see more application-specific alloys being developed specifically for additive and an application, right? So you definitely not only see that from a workforce side where you have these specialized individuals, but also the technology is, on one hand, versatile enough where it allows for that specialization for very specific use cases. And I liked your drone example. Also, I think very timely, right? I think there's now also talks about will DJI lose its license to sell drones in the US? Those are all, the majority of Class 1 drones we see today are from that manufacturer, and therefore you could see a very interesting time coming up pretty soon where you could see a lack of supply in the US of these drones, and additive and other technologies could fill that void. But for that, to your point, we need those innovators, entrepreneurs, and engineers to think about how to use additive in our case to fill that void. Now, if I think back also to my time in university, additive was still just considered rapid prototyping, and you didn't spend much time on it, even though I have an engineering degree. How has that changed over the past 10, 15 years from your perspective? If I'm either going through an engineering degree or even going through a community college degree in as a technician, for example, for certain fabrication methods, how much of a role does additive play in standard education programs today?
Oh, it plays a tremendous role. And I'll sort of give you a couple thoughts on that, right? And again, reflecting on where we were, where we are, right? For a really long time. So let's just think about, I'll go sort of like K through 12 through undergraduate university, right? For the longest time, it was just all about access. Like, can you get access to a printer? And in certain ways, I think this reminds me of stories that I've read or talked to folks about the early days of computing. It's just getting access to the tool.
Yeah.
Now it's ubiquitous, right? I mean, again, some really terrific innovators across many modalities, many regions of the world. They took the cost out. Not only did they take the cost out, they made the software easier. Like, I remember the first polymer filament printer I had. It was awesome. But like, you really had to be sort of like an enthusiast and really get into it in a way that you don't need to today. So when I travel out, talk to schools, community colleges, career and technical education centers, universities, it's amazing how ubiquitous the availability of the entry-level polymer tools are, and how much people know and understand them. Like, they're at public libraries, they're in people's basements. It's kind of like everything we talked about. We're like, as an industry, like, is this really going to happen?
Yeah.
And, some really brilliant people were like, oh yeah, everybody will have one in their house. I was like, is that really true? Like, and it's funny because as much of a technology adopter as I am, I'm always like, is that really going to happen? And then so, um, so I think the access is there. It's also super ubiquitous, maybe like even in certain ways overly ubiquitous, because if I think to matriculating students who are interested in, let's just say, any kind of technical career generally, you know, unless they're going to, like a technical high school, they're not getting experience with shop class or machining or even like woodworking really in their personal lives or in their schooling. So like in a lot of cases, the first manufacturing tool and the first CAD CAD to part experience they get is a, filament-based polymer printer, or maybe a resin-based polymer printer, which is like completely an interesting difference. And so I would even say, let me say it this way. I have not visited a single CTE, career center, technical high school, technical community college, or university that does not have 3D printers.
Wow.
It just doesn't exist. And so it creates a different set of challenges because, then you're trying to help these students and young people and people that are upskilling understand the rest of the manufacturing universe through this. They've walked through this doorway through 3D printing, right? Which is really kind of interesting because the longest time in my career, it was always like, oh, hey, we got these 3D printers too. And, the manufacturing people are like, I don't, it's kind of slow. It's kind of expensive. Now it's like everywhere. I'll give another just small anecdote, though, which I think is a very optimistic one. My experience was, a lot of the students that I worked with when I was in academia was students that would learn traditional manufacturing. There was whatever. There's always a certain rate where they sort of get into it or they have less interest and they end up finding other things. The students that came into the 3D printing lab are like, 3D printing super awesome. I'm going to 3D print everything.
Yeah.
And then they like run into these challenges and you're like, oh, by the way, here's a CNC machining center. And like, do you know how great CNC machining is? That part that took you like 4 days to print, you can machine it in like 10 minutes. Like, so because they run into all these challenges. Again, that's not saying, obviously 3D printing has tremendous value. It's what I've dedicated my career to, and you too, in your company, in our institute. But like the stickiness into manufacturing for the students that came in through the 3D printing doorway versus the other door was much higher. It's purely anecdotal. My hypothesis is that's because it's from a product design perspective. So it's and maybe this will be a challenge we'll have to address as the industry continues to evolve, but just because of where the industry is and because of what this tool is all about, it's less about build to print, and it's more, and I don't mean like 3D print build, but I mean like, here's your print, make this part, bang it out. And it's more about product design. So you're coming in with this, right? It's this terrific design thinking tool. Young people get a taste of that and they really want to go keep pulling on that thread.
Yeah.
But it's a really fascinating place where we're at, I think.
100%. And it's an interesting challenge that you now describe that you have students not understanding conventional manufacturing, but only additive. And I would even add to that there's still not that much exposure to true industrial additive technologies, right? I still
Yep.
meet a lot of students. I like to talk to a lot of, for example, student racing teams and rocket teams, right? They all have an interest, and very often they just recently found out you can print metal, but they've been using FDM and polymer printing for a very long time, right? So there's still that gap of the
They're like, yeah, you can print metal. You're like, you guys,
yeah
that's what I've been working on for like,
and
that's what our founder and director, like,
you're
my company was founded like 40 years, or whatever it was, 30
35 years
just
ago,
doing
yeah,
that stuff.
yeah, and they're right mechanical engineering students. So I still see that also, not only that gap to the conventional side, and I also still see that gap to the industrial additive component that sometimes I think is also overlooked in education. Do you see that as well?
Well, I think that's well, I think that's the challenge, right? Is where does it go from? Because now we just have all these end market niches, right? Like it used to be like, oh, additive's cool, right? Talk to your friends, over coffee or whatever, over lunch. And it's like, I really want to stay in, it's like, okay, well, I gotta stay in the additive industry, right? Because it's like this really cool little niche industry. Now it's like it touches all these other industries. And so it's like, well, what's the crossover point? Right. And then again, I'm sure you see it. I see it. It's like, well, people will try to push the boundaries of what a tool is appropriate for. Right. And you get in, it's all this discussion on form, fit, and function. It's like, well, form and fit is one thing. And there are a lot of, again, sort of consumer facing industries where form and fit, and then you get into like cost and volume, that's really what drives things, and then this whole suite of really industrial additive technologies enables brand new metal alloys, things you couldn't make any, or even leaving, sort of the aerospace piece aside. Like just look at biomedical implants. I mean, or even more simpler. I don't think we talk about it enough as an industry. Like the dentists are just continually innovating in the background, and it's sort of like its own separate industry. But like, I remember going around to all these talks and talking about how, well, in the EU, they're 3D printing all these metal bridges and crowns and pieces, and you show the plate of teeth, right? You remember those days?
Sure.
Now it's like, oh yeah, every city, every major city in the country either has a service bureau or some service, or the dentist has one in their office, and they're 3D printing and curing all of your ceramic, fillings and crowns. Like, whoa, like when did that happen? Like,
yeah, it's often understated how old serial production is in additive.
yeah,
And even how broadly adopted it is today in various sectors, right? I mean, we just talked to Siemens from Siemens Energy, Elia. He's a R&D manager there. I mean, they've been developing additive production applications for more than a decade now, right? And are truly pushing the limits of the technology. But that also still means that you need very, very specialized, highly knowledgeable people to push this technology forward. And it's honestly not different than any other technology, right? If you're a casting house, you need somebody who really understands casting, right? If you're a machine shop, you need the technicians that are wizards in setting up a unique toolpath. So we're not getting away yet, even with AI, from having highly experienced engineers. But we also, and that's probably a challenge across manufacturing, right? Even in those conventional technologies, you have the old guard that's retiring. You don't have a lot of millennials or Gen Zs that chose the manufacturing or engineering path, as in the past, where Also probably due to the trend of offshoring manufacturing. And now we're at this interesting point where we have new technologies like additive becoming super mature and ready for production. We also want to reshore manufacturing. We don't have the talent pipeline to feed all of that, but also not really the pull yet from manufacturing. So we're in this weird in between phase of we know we're going to need a lot of talent. We know we don't have the talent today, so we need to do various things, right? We need to upskill existing workers. We need to get the new generation interested in manufacturing. And that's also where America Makes, I can imagine, plays a significant role as a spider in that spider web to make sure that we can fill the pipeline and that we do a good job of reskilling existing workers. So I'm throwing a big challenge at you right now, but how do you wrap your head around that problem, and how can companies also prepare themselves for that talent challenge, but also opportunity?
Yeah, and I think, let me take that last point and let me try and get back to sort of what I was thinking about in terms of how I frame it when I talk to people, and mostly talk to students, right? And like, to me, I'm like, there are institutions out there, principally, like, I'm thinking of, I don't know, I was talking to somebody at a conference where it's like, the US military brings in young people very early in their life, and in 2 to 3 years, they learn how to do arguably among the most challenging things in the world, depending on what their, MOS or requirements are. I mean, let's just talk about it from an engineering perspective. I mean, you obviously there's a ton of expertise that's developed over time, but just in terms of competency entering into a, active duty, service environment where young people in, 2, 3, 4 years from 18, 19 years old are learning in very competent, relevant ways how to operate multi-million or multi-billion dollar pieces of hardware.
Yeah.
Granted, with a lot of guidance, right? But like, it's all there. And actually that probably drives some of the product development cycles in terms of usability, right? And like creating with the user in mind, which to me, how I like to think about it when I talk to students, or anybody really, all the listeners for the Additive Snack Podcast, is I like to think about it in terms of like, well, here's the state of the art. Here are some case studies. I'll give you one, maybe two examples of what I'm thinking. And like, here are opportunities to go add value. And to me, it's just like, there's so many opportunities once you sort of get into the space. And maybe it's just, again, where I'm at in my career, where it was like, I was sort of sharing, when I started, I was like, oh man, I'm like late to this game. I had conversations that I still laugh about with former, colleagues and still friends, where it was like, are we really going to go do this? All these people, in all these areas are already doing this, aren't they, Ed? And I'm like, we're going to take out 90% of the cost and increase the productivity by 10x. And then this is really going to make a new business unit. One of my favorites that really lands well with young people, right? Obviously, additive manufacturing is widely used in high performance motorsports.
Yeah.
And if you're a super nerd like me, I love reading the Formula One regulations, which are all published publicly. And if you read those over time, to me, it's one of the best primary sources of where the industry is, because I remember it's probably pre-COVID. There were like, it was definitely pre-COVID because it was before the cost cap for development.
Mm-hmm,
so you had these super teams, and there were specific line items forbidding the use of metal printing in certain parts of the car, which to me is like really, really interesting. Because if you peel back that onion, what it tells you is, with enough money, you could do those things, but you really had to have core expertise. So if you look at it as a historical document, it was like, well, you couldn't use it in certain parts of the braking system, certain parts of, let's just call it the powertrain. And now there's specifications on the alloys and modalities that you can use. So it went from you can't use it because they knew that the big teams that weren't encumbered by a cost cap were absolutely doing it with industry leaders and university leaders. And in fact, they had already done it. They did it. It was an unfair advantage. So they restricted it, right? So it's like a 3-step. They did it, didn't tell anybody they're winning the races because they had the fastest car.
Yeah.
It got restricted, and now it's a specified, you can use these alloys.
Yeah.
Now, and like, well, now it's being driven by design and cost and, okay, can I iterate each weekend between the races? So it's like, to me, that's a good thread of kind of where the opportunities are and are emerging. But that's how I frame it up whenever I go out and talk to these groups, and it seems to resonate. It's like, well, I think the one other thing I was thinking about is the challenge with telling that story really well, although this is, for some reason, I don't really know why it's changing, but so much of the innovation has been internal to companies, right? And probably internal to a lot of existing companies. So there's been some high profile businesses that have had challenges in this industry, and that's driven some of the, maybe just the general layperson narrative, right? But if you peel back the onion and just with a little bit of understanding, there's been like 10 or 50 or 100x successes, right? You mentioned one of our member companies that's been a great partner, Siemens Energy, right? I mean, they have gas turbines all around the world that are more durable, lower emission, lower total cost of operation because of metal printed parts in business, real business high temperature portions of their engines.
Yeah.
Right. Like, and I mean, we could go down the list and just look at our America Makes membership list or your partners there at EOS. So like, part of it is getting that story out. And then so kind of the third part, it's always interesting because I go out, I tell these terrific case studies that, partners have done or different projects that, folks have worked on with our stakeholders and our institute. And then they're like, they'll have one of two responses. They'll be like, oh, again, like, well, additive's good for everything. Let's just go do more additive. Or it was funny. I was talking to a group of high school teachers, what was it? It's like the American Association of High School Physics Teachers. And I gave basically the same talk I had just given to a university chapter of Society of Manufacturing Engineers. And these teachers were so savvy because the students in the SME chapter were like, oh, heck yeah, like I'm going to go make Formula One parts, or I'm going to make jet engine parts. Hey, Ed, which companies should I go apply for? And, this high school physics teacher was like, you talked about how like additive can do everything. Isn't there a place for traditional manufacturing? I was like, oh, that is whoa. Like, I don't know. It was just so cool.
Yeah. He got it right away.
But he got it right away.
Yeah, that's awesome. As a physics teacher, I always looked up to my physics teachers in high school. And well, you make a few really interesting points. I just went to the F1 race in Austin a couple of months ago, and it was close to after I'd interviewed Stefan Seidel from Punkel. He's a CTO at Punkel, and Punkel is this Austrian contract manufacturer that supplies a majority of the F1 teams with additive parts. One part that most folks don't even know is printed nowadays is the air intake over the whole air intake structure over the driver's head, which is one of the most safety critical parts of the whole vehicle, right? If your vehicle flips, that's what it lands on first, and then you also have the halo that helps to prevent any injuries.
I knew about the halo. I didn't. Now I gotta go watch the episode.
Yeah.
That's really interesting.
Yeah, super interesting. And it's just this thing that nobody even knows. It's not even mentioned in any of the F1.
And you can't see it,
can't see
right?
it.
Like it's all whatever coded or wrapped. And they probably want it that way, right? Because I'm sure there's little tweaks.
Yeah, there's some competitive advantage in there. But which brings me to your other point, which is then therefore, additive is in way more parts than folks know, but they should probably know about. So we do also have some work to do in the industry to push out of our little additive bubble and get back into the general public, where we used to be for a little bit when we hit peak hype. And then nobody talked about additive anymore. But now actually the real stuff is happening. So that's the one piece. And the other piece that you mentioned about the military being able to like train highly specialized people in a very short time also really means to me. And if you now combine that with, okay, we have AI starting to also play a very big role in education. You start to have to think about robotics and automation. So there's also a lot of new trends all intermerging into manufacturing. And then you have companies like Palantir or NVIDIA that start to publicly say, if you want to work at our companies, you don't need a master's degree or a PhD. You need grit, you need the willingness to learn, and the right attitude, because your job profile is going to change over the course of the next 20 years, probably 5 times. All that brings me to a question I have for you, which is, what does that really mean for education as we look at it today? Do we need to rethink the way also companies hire for AM engineers or AM experts? Do we need to rethink the way that we teach? The duration of some of these education programs, etc.
Yeah, I sort of think so. Again, like when I talk to students, I try to be really thoughtful when I answer this question, and I sort of answer it with a couple different points. So I'm a firm believer in a T-shaped expertise, if you're familiar with this concept, right? So like broad and deep in a couple specific areas. So just like reflecting on my own personal journey of having a passion for material science, and particularly for high temperature ceramics and metal alloys. I actually wasn't exposed to additive until a few years after finishing my PhD. Like I didn't even know what it was. Mm-hmm. And when I had the opportunity to, get some exposure and start working with these tools, it really served me well to have that deep domain expertise and sort of approach this suite of technologies with my own sort of perspective there. And I think too, like, that's what makes this industry really fun, is because you have such a broad group of different backgrounds, right? Like there are folks that, get really into the software and design side. There are folks that are, that are like plumbers and, gas folks and mechatronics. So like, there's just a ton of access points to add value. So from that perspective, again, it's sort of this T-shaped expertise is what I am an advocate for. Mm-hmm. And I think that needs to be contextualized for an individual learner. So if they're a transitioning veteran and, they have their allied trades expertise and they were working on large, motors or engines or as part of a maintenance battalion, that's going to look different than somebody who, is coming out of, skilled trades, or somebody that's coming out of a university path. and there's all ways to contribute to the industry. I think the other thing, though, that I'm really, really adamant about is, this is a hands-on industry. It's and I don't mean that like in a broad brushstrokes, like to make a industrial part, right? Again, I'm talking form, fit, and function. I don't care your material class, polymers, metals, ceramics, and biomaterials. There's just so many technologies coming together that like until you get a system and you wrap your arms around what it can and can't do, it's impossible to really understand, number one, what it can do, and number two, what it can't do. Mm-hmm. And so that's the other piece. So students ask me that question.
Yeah.
And I talk about it. I talk about T-shaped expertise, and I talk about the importance of being hands-on, because again, if you just read about it, and I don't discourage people to just read about it. You should be an expert and be well-read and all those things. But if you just read the trade press, it can seem like a replicator from Star Trek. And it can seem, again, like when I joined the industry, felt like all the problems were solved. I mean, we said the same things. Oh, it can be used for race cars or implants or all this other stuff. And it's like, well, actually, there was like so much more we could have been doing, mm-hmm. or ended up doing, I should say. I want to make sure we're coming to the end of our time. If you have a follow-up to that one. But one thing I do want to talk about is one community we haven't talked about from an education and workforce perspective, and that's the investment community and the role of additive education in helping to make this industry understandable and investable. Because that's one thing I've thought a lot about too.
Yeah. Do you want to talk about it now? I have one more follow-up question to what you just said. But let's actually.
Well, why don't we do that?
And first. So, because I totally agree with you. The hands-on aspect of education is oftentimes actually overlooked and under-delivered in various educational institutes and even in professional education programs, right? And in today's world where a university's USP is most likely not holding knowledge anymore because it's out there, right? You'd be surprised how much ChatGPT knows about laser powder bed fusion. You don't need a professor to teach you laser powder fusion anymore, but you don't have access to the technology and you don't have hands-on experience, and that's where I see truly the role of those types of educational institutes. And with that, I could see more value now than ever in apprenticeship type programs, which are still somewhat rare in the US, but very broadly adopted in other parts of the world, for example, in Germany. Do you see a rise in those types of truly hands-on programs, also in collaboration with companies, to also bridge that gap and accelerate the learning journey and provide the vertical piece to your T?
So there's a lot of interest out there, and I think the way I'll answer the question is this, where I think America Makes as an institute can add the most value, and where I think the most value to be added, it's sort of like a last mile problem. So going back to a thread we were talking about. So there's ubiquitous access to entry level form and fit polymer printers, mm-hmm. right? And so there's ubiquitous access, and I would even say like ubiquitous education opportunities in entry level CAD or product design and those polymer printers. And then there's way more access than people realize, but just to the more advanced technologies, right? And there's just barriers in terms of, I mean, frankly, the first barrier is safety, right? Which in engineering and production is always number one, right? And it just requires a different bar, both in terms of your facility planning, but also personnel. training. So there's just a higher bar to access the technology, let alone the capital investment. And, it's probably more regional than local in terms of, let's just say, getting your hands on a 7-figure metal printer. So I think that's where I sort of talked about the 3D printing for what end market. And that's important, not just from a learner perspective, but that's important because that's where you get into these industry groups or local clusters of companies that are actively recruiting folks. So there's a connection point there. And then just connecting all of these interested and passionate educators with each other, because, sort of the way that education or workforce or any of these things are done in the US is really about, people have a niche that they go serve, right? So it's like, I am a high school physics teacher and I really understand how to help students of a certain age, to learn and progress in their career, or vice versa, right? Even if you look at the university level, there tend to be faculty members or staff members that are specialists in educating undergrads and meeting them where they're at in their particular time of life. So I actually don't necessarily think, like, look, we should continue resourcing, but I think the resourcing is there. But then there's all these hard yards of sort of matrixing and bringing those folks together and sort of stepwise, like, okay, I can use a filament polymer printer. Well, should I jump to a metal powder bed laser powder bed fusion
Or
machine
DED,
in polymer or DED, or like what do I go do next? And how do I go do that in a way that's, safe and, timely for again, I think that's the other thing is there's so many options. People that are passionate about it can sort of find their pathway. But that to me is the challenge. I think there's lots of programs, lots of investment out there. I particularly see it at the, let's just call it 15 to 25 age group cohort of, CTE programs, career centers, community colleges. They have tremendous assets, but their connection, where they need support, is the connection to industry. And it's even as simple as, like, they work on different calendars, right? The academic calendar versus the company calendar, particularly local small businesses. I'm not even talking like publicly traded quarterly calendar, fiscal year. I'm like, they're trying to make payroll every 2 weeks, right? And like, they just got a big order and they want to know if they can fill it, and they need to find 10 people. Like, that's just where they live. Now, the CTE programs that are doing this really, really well, I mean, they have industry networking and matriculating students coming out every 12 to 16 weeks. But that's a different level of depth that you're getting versus, a multi-year program.
Yeah.
I don't know. I see a lot of activity. I'm very hopeful. Maybe I'll sort of say it that way. I'm very, very hopeful of where we're at and where we're going with that.
Oh, me too. This is the most optimistic I have been about the additive industry in a very long time. Right, ever since our hype phase. And I agree with that. Education institutes and industry have to move closer together. I think they have moved closer together already over the past years. And there's still a little bit of work to do, but we're definitely on the right track. All right, now you mentioned capital allocators. What role do they play in growing the industry, in growing the workforce? What's your point of view on that?
Yeah, and this is something Kimberly and I are collaborating on. And, I was fortunate enough to have some terrific collaborations and direct experience with a few really amazing leaders in this field over the years. And so I think part of it is for us to continue to grow as an industry. Like, I'm talking growing revenue, growing orders, we've got to be more investable as an industry. And that's a challenge because we've been so engineering driven for so long, right? And that's got to keep going. And I think if you look to some other industries that haven't stuck the landing, they've gotten away from their engineering roots, and they've sort of atrophied over time. So there's like a risk reward here. But to me, what I'm most interested in, or I should say where I think the most value is, like just simply telling the story in a language that's investable. So what do I mean by that? We've got to talk about total addressable end markets. And it can't be, or I should say it's insufficient for many capital allocators to talk about, oh, it's going to be $20 billion, or I don't know, pick a number, 30 billion. You could pick any report you want. You could get a different number in a macro sense. That's not how the best capital allocators I've worked with make their investment decisions. They want to know this region in the next 2, 3, 10 years, my total addressable market's going to be $53 million or something for this specific business, right? Like the level of specificity has got to get higher. The other thing that correlates to that is a level of market segmentation that it does not exist. It doesn't exist openly. It doesn't exist privately. I promise you that. And that goes around with all the other things we talked about in terms of like, here are the end market verticals. Here are the end market niches. Tear down a gas turbine. It's not the gas turbine industry. It's like the combustion systems repair industry, right? Like we've got to get to a level of if we as an industry want to go from I'll just pick a number, from a $15 billion custom niche machine tool industry to a $100 billion broad shoulders national, internationally relevant industry. That's what we've got to do.
Yeah.
And that requires a lot of specialists. And that requires people that can translate true rubber meets the road risks and opportunities of where the industry is. And again, I'll just leave with one super technical example of which I'm very passionate. And that's all this beam shaping work and advanced optics, because in my technical opinion, and I think a lot of our stakeholders and members, it's like, okay, well, that's one of the key foundational pieces to truly unlocking just volume productivity and ultimately dollar cost productivity. And it drives me crazy that now I'm old enough where I'm like, oh, we talked about that 10 years ago. And by the way, it worked 10 years ago. Okay. And like, people are still like, I don't know, I'll buy one, I'll put it in the lab, I'll put it in my favorite university. Like, come on, guys. Come on. Like, so that's one where I think there's an opportunity for sort of like a risk arbitrage, because the people that are adopting the technology, and that's actually an engineering problem, not a finance problem, but they go hand in hand. The perceived risk is higher than the actual technical risk, in my opinion. I don't say that I just say that as an example of the level of detail and specificity and sort of technically driven investment decisions that are going to be required for this industry to take our next 10x jump. Because I don't know, pick a number. We're at 10, 20 billion. Done. Boom. Done. We're at $1 billion, whatever, 10, 15 years ago. We 10x that. You want to 10x it again? Well, this is what you got to do. You got to be able to go tell that story cogently to really, really smart, willing to take risk, financial risk professionals who look at all kinds of really, really interesting industries. And our industry has to do a better job of doing that. I think that's actually an education problem, not a technical problem.
Well, it's both, right?
Yeah.
It's both. You need the educated folks to break down the technical problems, simplify it, and create trust in the available data that we have. That in your case, that suggests that beam shaping creates oftentimes actually better material properties and increases productivity significantly, right? And not now spend the next 10 years validating that statement. And I'm also hopeful that tools like AI will help in those data verifications and accelerate the adoption of those types of trends. And then, yeah, to your other.
It's probably my favorite, one of my favorite Jensen Huang quotes from NVIDIA. He tells a story. It was his commencement speech he gave at his alma mater, which I think is the National Taiwan University. He was talking about meeting a physics professor. Now, this was before they had sort of like, and I don't remember all the names of the chips, but this guy had bought a bunch of gaming GPUs, 15 years ago, and had them in a closet and was running like, fans that you would have at your house to keep them cool. And, he was talking about, the anecdote goes, this professor thanked Jensen about how he enabled him to pursue his passion for scientific research through these advanced tools. And again, what a great crossover point, right?
Yeah.
Like, these are advanced tools. Our industry needs to use them in order to advance all these different interest areas to go add value.
For sure. And we need education, we need the industry, we need innovators to all work together. It's funny you say that. I just listened to a long form interview with Jensen yesterday, and he mentioned his whole life story. And yeah, I mean, ultimately, the folks that identified that GPUs are great for backed in a new concept called machine learning were researchers at a university, right? And he picked it up and ran with it, and then developed a chip that was more accustomed to that problem statement. Right, man. I don't think we can end better than quoting Jensen from NVIDIA. Once you hit that level,
actually, I have one more thing to share. Can I share one more thing?
Of course. Yeah.
Just a little insight, since I'm like fidgeting here. So these are, what am I fidgeting with? So this is a pirate doubloon from the Pirates of the Caribbean movie that my grade school daughter, she makes me these on our little polymer 3D printer.
Oh, that's cool.
And I'm like always running around traveling, and I carry them with me.
Is that currency in your household?
She used to give them out to people, to friends. So right now, it's just like I guess a household meme token without, residual value, but a lot of, personal, emotional value. But
you should
to me, that's why, like, she's not even that into engineering. She's more into like healthcare and animals, but like, that's kind of where we started, right? It's like art and engineering together. And you can make these things. You can make products that you want to make in a very straightforward way. Using 3D printing.
And who knows? Maybe your daughter is the next generation of additive engineers. And we had Paul Gradle on the show, and he talked about how his kids use their FDMs. His son is more on the engineering side, printing complex part. His daughter is more on the artsy side, and she's printing even jewelry. So yeah, I think to your point, having these desktop printers at home definitely sparks the creativity and also the interest in manufacturing and design for our kids. Well, see, we ended on an even better note than Jensen. Ed, it was awesome to have you on the show. It was awesome to talk about education, workforce, but also really where the whole industry is as a whole. So thank you for being on the show. Also, thank you for all the work you do at America Makes. It's a great service for all of us in the industry to inspire and motivate the current and next generation of engineers, technicians, leaders, decision makers to really push the industry from the 20 billion to 100 billion. So thanks for being on the show today.
Yeah, thanks, Fabian. Really enjoyed it.
And to our listeners, thank you for tuning into our 2-part series with America Makes. If you're interested to learn more about America Makes, check out their their websites. If you are a manufacturer, also consider becoming a member and joining some of their events. Always great networking, but also always really awesome insights into where the technology is at today. If you like this episode, share with a friend, colleague, anyone who wants to learn about additive or where the industry is at today. I'm Fabian Ahlefeldt, and this was the Additive Snack Podcast, and I'll see you next time.